Okay, now let us look at this example. It says I have something divided by something, then over here I have 2 to the power a, 3 to the power b, x to the power of c. Then I want you to find the value of a, b, and c. Now let's recall, when I say 2 to the power x is equal to 2 to the power 3, then we say that, oh, the base is the same. Now I've been saying this quite a few times. So base is the same, then the power will be the same. So similarly here, if I have two different base, 2 and 3, over here is 2 and 3 as well, then we say that, oh, because I have 2 and 3 here, 2 and 3 here, then the x must be equal to 4 and the y must be equal to 6. Now say for example, I have another one. I have 2 to the power of x to the power of y times a 2 here. Now over here you have 2 to the power of 4, 3 to the power of 6. Can I also say x is equal to 4 when there's an extra 2 here? No, very good. So now we know we have to combine them into 1. So in this case, I'll make it into 2, then x plus 1, then the whole thing. Now I can compare the base of 2 and then the power. So x plus 1 is equals to 4, y is equals to 6. So now that you understand, you have to combine everything into a single term. Can you now solve question 5? Okay, for question 6, we want to solve this without using the calculator. Now we want to recap some of the things again. So number 1, we say that root 3 plus root 3 is like apple plus apple, and we say that we have 2 apples. So what if I have 5 root 7 minus 2 root 7? Oh, we say that it's like 5 apple minus 2 apple, and I have 3 apples. Now what if I have root 98 minus root 50? Now we all know that the base is not the same. Then we cannot just say, oh, apple minus orange is equals to something, something, something. So we need to change this surds into the same surd as of part 1 and part 2, where I have root 3 and root 7, I can combine them together. So in this case, I want to break them into smaller surds using the square number. Now how do I do that? Now first, square numbers is like numbers like 4, 9, 16. And how do I get this number? We say that, oh, this is because 4 is equals to 2 square, 9 is equals to 3 square, 25 is equals to 5 square, 64 is 8 square, and so on and so forth. So what it means is that 98, I need to divide by any number here and give me a whole number. Now I want to find the biggest number. So I will not choose number like, let's see, never mind. For 98, I can divide, and then you see that 49 is the biggest number that I can divide 98, and there's no remainder. So you know that 98 is 49 times 2. Similarly, 50 will be equals to 25 times 2. Once we have this, I can actually break them up into a smaller set. Like this, in this case, this is root 49 times root 2. This is root 25 times root 2. And then root 79 is equal to 7. So I have 7 root 2 minus 5 root 2. So from here, because it's the same set, I can then write out my final answer. Now remember, simplify the word simplify here. They do not want you to find the exact answer. They want you to live in terms of sets. Okay, now for 6b, for these numbers, they are quite big, so most likely I want to break it up into, because this is root 5, so I want to express this in root 5 something, this also in root 5 something. Okay, can y'all try now? Okay, when I say root 5 something, means I want to break this maybe into root 5 times a number to get 45. So maybe it's root 9. So this is root 9 times root 5. And I can simplify this and say this is 3 root 5. Okay, now the next part of the chapter actually talks about rationalize. So let us revise on the word rationalize. Rationalize means I want to remove surds in denominator. So in this case, I see 2 over root 3. How to remove surd? I need to multiply by the same number and the same number here. So in this case, I put root 3 over root 3. Now why do I want to choose this number? Because we know that root 2 times root 2 is 2. Root 3 times root 3 is 3. And root 5 square means root 5 times root 5, which is equals to 5. So in this first example, the answer is actually equal to 2 root 3 over 3. So I want you to observe that this number here, there is no surd denominator compared to the original one. Now, there are two types of rationalize. One is to multiply by the same number. Another one is when I have two terms like this. Now I cannot multiply by the same denominator, but instead I will multiply by opposite sign. Like if I have root 3 minus 1, I will multiply by root 3 plus 1. Now when I do that and I expand, you will see that I will not have any denominator. That is called rationalization. Now, can you try to rationalize this example now? Okay, same kind of question when they want you to rationalize. What happens if I have things like root 2 times root 2, or we know is equals to 2. Now, what happens when I have 3 root 2 times 4 root 2? So what I want you to see is actually you can rewrite as 3 times 4 over here and root 2 times root 2. Now we all know root 2 times root 2 is 2 and 3 times 4 is 12. So can you see that when you do this, you don't have to actually use a calculator. Then of course you can use a calculator to check back. Press this in the calculator and see that you get the 24 as the answer. Now, so when we do faster, we want to see that 3 times 1 to give you 3, root 2 times root 2 to give you 2. Similarly, when I have root 3 and root 2 like this, the number is different, and based on the indices law, now let me write out the indices law. It is a to the power of m times b to the power of m is equals to ab to the power of m. So we say that root 3 times root 2 will be equals to root and then the 3 times 2, which is root 6. Now that we understand this for example, can you now try out the 1, 2, 3, 4, 5, 5 example here and tell me the answer. Now once you have the answer, can you now rationalize this question and tell me the final answer? Hooray! Now all of you have got 7A and B correct. So now I want to look at 7C. 7C, I see that there are two different fractions here. Now what you want to do is you want to group them into one single fraction. So grouping one single fraction, if I have 1 over 2 minus 1 over 3, I want to change this to same denominator. And once I have that, then I can say, oh, this is to the common denominator 6, and this is 1 times 3 minus 1 times 2. Now remember, when you see a negative, it's better if you put a bracket behind, so that you don't get any careless mistake. Now try to do this. Don't forget, after you simplify into one fraction, you have to rationalize. And what do you have to do for rationalize? Okay, now that you get question 7C correct, let's move to question 8. Now, question 8 has a triangle here. Now, the question itself is not difficult. The only tricky thing is now they want it in terms of surds. So you want to recall, if I have a particular surd like this, when they say I want you to express in the term of a plus b root cube, you notice that there is no denominator. Now, so from something like this to something like this, no denominator means I need to, very good, rationalize. Okay, now question 9 is the new topic that we have gone through earlier on. It says here the roots of this equation is alpha and beta. So they want to find alpha square minus beta square. Now, let me write out the steps that you need to do. Now, first step is always you have to write down the old roots. You have to write down A, B, C. So old roots in this case, let me underline. It is, according to the question, it says alpha and beta. So I write alpha and beta. And A, B, and C I can get from this equation here. Now remember, when you do not know what else to do, you can always write down the sum of all roots, the product of all roots. Now, once you have written that, then you want to see, oh, what is this alpha square plus beta square? So you know that, oh, alpha square plus beta square is actually alpha plus beta, alpha minus beta. Now, to find alpha plus beta is easy because we know that this is actually your sum of roots. But how do I find alpha minus beta? Now, to find alpha minus beta, we know that alpha minus beta square is, after I expand, I will get something like that. Alpha square minus 2 alpha beta plus beta square. After I rearrange, I'll have alpha square plus beta square minus 2 alpha beta. So this alpha beta, I can get it from the 2. 2 refers to this one. Now, what about alpha square plus beta square? Very good. We know that alpha square plus beta square is actually alpha plus beta whole thing square minus 2 alpha beta. Now we have done this in class, and how do I get this alpha plus beta square? Again, I can get it from 2. And how do I get this? Again, I can get it from 2. So once I get this value, this will be a number. I can put it back here. And once I get this number, I can put it back here. And then I take a square root. Then I will have this number. And with this number, then I can have this number here. Watch the video again and try and understand question 9. I'll see you next slide. Well done. Now that we have solved question 9, let us go to question 10. Now question 10 says I have this equation and I don't want to solve this equation because I want to find the sum and the product. So whenever you find the sum and product, remember you have to write down what is A, what is B, and what is C. But in order for you to do that, based on this, it's very hard for us to find A, B, and C. So we'll do a cross multiply. So I write here cross multiply, and then I will shift everything to left hand side until I have ax squared, bx, c, and then equals to 0. Now make sure your right hand side is 0. Then you can tell me your A, B, and C. Okay, now it's your turn to try. Yay, now that we solved 10a, let's go to 10b. Now 10b is all about understanding the question. So in this case, it says one root is the negative of the other. Now if I write it down, it means if one root is alpha, the other root will be negative. So it's minus alpha. So if I put here as beta, this will be negative beta. So I can put it as any alphabet that I want. But because in this topic we learn alpha and beta, so I will just put here as alpha. Now I give you another example. If I say one root is twice the other, it means that if one root is alpha, the other one will be 2 alpha. Now another example, if I say one root is 3, find the other root. Now this means that if one root is 3, the other one will be alpha, or you can put it as beta. Now note that this alphabet does not matter. If you put this as beta, this will be negative beta. So with this as the roots, can you now find the value of p? Now I give you a hint. This is actually solving simultaneous equation, which means you have to find out the value of p and the root, which is alpha in this case. Now you try. Okay, last few questions. Now we are looking at question 11. Now 11, 10a, I believe you can find the answer. So I'll skip it and then I'll go to 11b. Okay, now 11b says find the quadratic equation. Now again, this is a very common question. Now let's look at the steps. First, I want you to write out the O equation. And the O equation refers to x squared plus 6x plus 3 equals to 0. So let us write down together x squared plus 6x plus 3 equals to 0. Now then we want to write out the O roots. So O roots, I look at the equation, it says alpha and beta. So I put here alpha and beta. Now, what does the question want? The question says find the new equation when the root is this alpha minus 2 beta, beta minus 2 alpha. So I want to find out alpha minus 2 beta as my new root, beta minus 2 alpha as the new root. Then I need to find this new equation. Now before I can find this new equation, I need one more very important step. That is, I need to find what? Very good. I need to find new product of roots and new sum of roots. Now once I solve that, then I am ready to look at the new equation. Now what the number that I found, I will actually put in this number here and this number here, and then I can form the new equation. And remember, this is the final answer. You stop here. And also remember, for this new equation, you cannot have fraction. So I put here no fraction. So you have to multiply the denominator throughout to remove the denominator. Okay, now for 11c, this is something new. So I want you to copy this down into your notes. It says a minus b cubed. A cubed minus b cubed is actually a minus b, a squared plus ab plus b squared. So write this down and then remember this. Alright? Then similarly, a cubed plus b cubed is the same. It's something similar but different. Now I want you to observe with me how to remember this formula. So let's say I have minus a cubed minus b cubed. Remember, I always begin with minus. Then I will change the sign to plus. Now the sign behind is always plus for both expansion or factorization. So let us look at the second one. Second one, when I have a cubed plus b cubed, remember I always follow. So the first sign will follow, and then the sign here will change. So if this is plus, then this one will be minus. Now observe this also. This looks like the a square minus 2ab plus b squared. The only difference is now I do not have the 2. Okay, so take some time to remember this formula. And what we understand is if a cubed minus b cubed is this, then x cubed minus y cubed, I can replace the a with x, replace the b with y, and then I have something like this. So once you understand this, then alpha cubed minus beta cubed, can you write out your answer here? Okay, for question 12. Now this is exactly the same as 11b, so I want you to follow the steps and test yourself. I believe you can do it. So that's all for Common Test 1 revision. Now finish this worksheet and then we will go through in class.